Welcome to the DIY Honda Garage channel. Welcome to this diagnostic presentation on the DTC P16E3 error code, specifically related to the PGM-FI-Battery sensor LIN communication error for the Honda Pilot models from 2016 to 2022. This fault indicates a communication failure within the battery sensor's LIN, local interconnect network, communication line. This can disrupt vehicle operations, particularly functions dependent on battery status, like charging and power management. The battery sensor is critical as it monitors the voltage and health of the vehicle's 12-volt battery, helping the engine control module to optimize performance and efficiency. In this presentation, we will explore the components involved, causes of the error, symptoms, and step-by-step troubleshooting methods to effectively resolve the issue. The P16E3 is a diagnostic trouble code, DTC, indicating a communication error within the PGM-FI or powertrain control module concerning the battery sensor. The battery sensor plays a crucial role in ensuring accurate readings of the 12-volt battery's voltage, which is vital for various electrical systems to function correctly. It connects to the vehicle's local interconnect network, LIN, for accurate data transmission to the engine control unit. This sensor is located near the vehicle's 12-volt battery. When there is an error, the engine may not function optimally, as it may lack real-time battery condition data, which can affect the vehicle's performance and lead to battery-related issues. Several factors may lead to the P16E3 error code. Loose battery sensor terminals can prevent proper communication between the battery sensor and the vehicle's control modules. This is often a simple fix of tightening connections, but requires inspection. A faulty battery sensor itself can also cause this DTC. The sensor may fail, losing the ability to send accurate data over the LIN communication line. Wiring issues can also contribute, including shorts or opens in the LIN wiring, which disrupt data transmission. Each of these causes must be thoroughly inspected to determine the source of the communication error. When the P16E3 code is present, drivers may observe certain symptoms indicating an issue. Dashboard warning lights may illuminate, especially battery or check engine indicators, signaling potential battery failure or communication errors. Additionally, battery charging issues may arise, where the battery may not fully charge or hold a charge efficiently. This can lead to complications when starting the vehicle or operating electrical accessories. Moreover, poor vehicle performance such as hesitation during acceleration or inconsistent engine behavior may be reported. These issues stem from improper voltage readings affecting the engine management system and other connected components. In step 1 of the troubleshooting process for DTC P16E3, the first action is to turn the vehicle to the on mode. This is done to initiate the vehicle's electronic systems and allow for diagnostic operations. Next, use the Honda Diagnostic System HDS to clear the DTC and wait for approximately 5 seconds. This resets the system and allows you to monitor if the error reappears. After clearing, you'll need to check for any pending or confirmed DTCs through the HDS. If the P16E3 code is still indicated, the problem is confirmed and you can move to step 2. If not, it may signal an intermittent failure, prompting a check for loose connections or poor contacts. In step 2, begin by turning the vehicle off and then disconnecting the 2P connector from the 12-volt battery sensor. This disconnection is vital for safely measuring voltage without risking further damage to the components. Utilize a multimeter to measure the voltage between the test points, the first being the number 1 pin on the connector and the second being body ground. Conduct this test while the vehicle is in the off lock mode. If the multimeter indicates battery voltage at this point, proceed to step 3. If there's no battery voltage, it indicates a potential issue elsewhere, requiring a different diagnostic approach as outlined in later steps. Step 3 requires you again to turn the vehicle to the on mode. After transitioning to on, measure the voltage again between test points, which in this case involves test point number 2 on the battery sensor connector and body ground. It is necessary to ensure that the sensor is still disconnected during this measurement process. If you find that the voltage measures 0V, this suggests that the 12-volt battery sensor is malfunctioning, warranting a replacement. Alternatively, a reading above 0V signals a continuing problem with the communication line. Thus, you would need to proceed to step 4 to investigate further. In step 4, begin by turning the vehicle to the off-lock mode. The focus here is on checking for continuity between the number 2 terminal of the battery sensor connector and body ground. While performing this continuity check, disconnect the gauge control module's 32P connector and the heated steering wheel control unit's 14P connector. By disconnecting these connectors one at a time, you're checking if the continuity disappears, indicating a shorted wire issue with the LIN communication line. If continuity does go away upon disconnection, this indicates that the LIN wire is functioning as it should. In that case, replace the component that caused the circuit to open. Step 5 follows the same approach as Step 4, but focuses on another connector. Start by turning the vehicle off and disconnecting the gauge control module's 32P connector. As in previous checks, test for continuity between test points to ensure there are no breaks in the communication line. At this point, you will check the same number 2 terminal of the battery sensor connector to body ground. If continuity is detected, it signifies a short within the LIN wiring that requires repair. If no continuity is found, it indicates the wiring is likely intact, prompting you to follow through to Step 6 to explore open wire issues in the LIN communication line. In Step 6, you will be taking a more direct approach to determine if there are open wires within the LIN communication line. Start by connecting terminals A and B with a jumper wire, specifically the gauge control module's number 23 terminal to body ground. As before, check the continuity between the battery sensor's number 2 terminal and body ground. If continuity is confirmed, it indicates that the LIN wire is intact. If this is the case, a replacement of the gauge control module may be necessary due to internal failures. Conversely, if continuity is not found, this suggests an open wire case that requires repair between the battery sensor and the gauge control module. Step 7 focuses on checking electrical protections in the circuit. Begin by turning the vehicle to the off mode and examine fuse number B4, which is a 7.5 amp fuse located in the auxiliary underhood fuse relay box. If the fuse is intact, the next step is to evaluate the +B BMS wire, which connects the battery sensor to the fuse. If the fuse is blown, it indicates a short in the +B BMS wire, which requires addressing alongside replacing the blown fuse. It's crucial to trace back the circuit to fix any fault that may have occurred to restore full functionality. If the fuse is okay, yet there are remaining communication issues, proceed to follow through with diagnostics for the wiring and connection path. After completing all necessary repairs for the P16E3 error code, you undertake undertake a final verification process to ensure that everything functions as it should. First, confirm that all connections, especially those linked to the battery sensor, gauge control module, and any wiring that was repaired, are secure. Also, ensure the sensor itself is operating correctly and that any components involved in the previous steps are functioning without issues. After making these confirmations, utilize the Honda Diagnostic System (HDS) to recheck for any DTCs. The absence of the P16E3 code following these tests is a strong indication that the repairs have resolved the issue, allowing for the vehicle's return to normal operation. To avoid future occurrences of the P16E3 diagnostic trouble code, it's essential to adopt preventive maintenance strategies. Regularly inspecting battery terminals ensures that no corrosion or loose fittings occur, which can lead to communication issues. Monitoring the health of the battery itself through periodic voltage tests can catch early signs of deterioration before they lead to more serious problems. Additionally, conducting routine checks of the vehicle's electrical system can preemptively identify potential faults in the wiring and sensors. By staying proactive with these maintenance measures, you're less likely to experience unforeseen battery sensor communication issues, which can lead to inconvenient vehicle performance problems. In conclusion, diagnosing and troubleshooting the DTC P16E3, indicating a PGM-FI-Battery sensor LIN communication error, requires a systematic understanding of the involved components and their operation. Following the outlined troubleshooting steps methodically can lead to effective identification and resolution of the core issues causing the error. As we discussed, maintaining secure and clean connections, replacing faulty components, and conducting routine diagnostic checks are crucial in preventing similar errors in the future. By implementing these strategies, you can help ensure reliable vehicle performance and longevity, enabling a smoother and more enjoyable driving experience. Please like and subscribe to the channel. See you next time.